So at this point, we already understand that the process of building a predictive model is essentially to look at the underlying data, historical data, identify patterns. And based on the patterns, we say, well, the pattern we observed is basically our model. Okay, and the pattern may take the form of an algebraic equation, or it could take any other form. And one of the things we'll do in the course is to find many different forms of patterns. Okay, now we are going to look at how do you evaluate the quality of a model. Okay, so let's quickly recap what predictive analytics does. So you've got some historical data, you identify a pattern, right? So that's what we mean by saying the pattern is basically your model. Then you use the model to make predictions for new data. This is new data for which we don't know the total cost. We can apply the model and calculate the total cost, right? So we looked at data in which we knew the total cost and we knew the quantity. We saw the relationship between total cost and quantity. And now we can apply that relationships to new data where we don't know the total cost, but we still have the quantity. So we can apply the model. Okay, so this is really what the whole process of predictive analytics is all about. Okay, so how do you evaluate the model? So here we've got historical data from which we've built a model, just like we looked at the patterns and arrived at a model. The question is, how good is this model, right? So how can we determine how good the model is? So in this case, we took the historical data and we identified that the pattern, one pattern we were able to identify was the total cost is 2 times the quantity. That's our model based on historical data. Now, how good is this model? Well, one thing you could do is to check the model, right? So this is the model, this is the data, the same data as before, this data, okay? And this was the total cost. Now we apply the model, we found the model based on this. Now we apply the model once again to the quantity and calculate the total cost using our model, okay? And then we can compare and say, well, how good was the model prediction when compared with the real thing, right? Now in this case, of course, the model prediction is going to be exactly equal to the real case in every case because this model was an exact model, right? At least for the subset of the data that we saw, the model was perfect. There was no exception to the model at all. Now we saw earlier another case where the data was slightly off. It was not exactly 2 times. Sometimes it was slightly less, sometimes it was slightly more, sometimes it was exactly equal. Here is a case. So one way in which you can evaluate the model is to build the model and then for the same data generate model predictions and then see how good the predictions are compared to the actual values. Now one would think if the model prediction is very close to the actual, then the model is doing a good job. Okay, so in this particular case, the model predictions are accurate. We got an exact model. So is this a good model? That's the question we want to look at. I want to approach that question through an analogy that you're very familiar with, that of preparing for an exam. Okay, so let's look at that analogy. Now let's say you're trying to prepare for a particular exam and in order to get an idea of what are all the concepts that are going to be tested for the exam, somebody has given you a set of questions to prepare for the exam. Okay, so what we are saying is that those questions are representative of the kind of concepts which are going to be tested in the real exam. Okay, so in other words, if you're able to understand all the concepts that these questions cover, then you should be expected to do well in the real exam. Okay, so you've got a set of questions and you use those questions to study for the exam, right? So you said, okay, here are 100 questions and you went and read up on the concepts which are in those 100 questions. And of course, they gave you the answers as well, right? So that you could study and then you said, oh, this is the question, that's the answer. Okay, I understood that. And then you went and maybe did a little extra study to strengthen your understanding of those concepts. That was your preparation for the exam. Okay, now suppose you want to find, you've done your study, you want to find out how ready are you for the exam. How would you test yourself? Well, one thing you could do is you could test yourself on the same set of questions to check for preparedness. So let's say somebody gave you 100 questions. you studied, and answers. You studied with those questions. Those questions give you a good idea of which are all the concepts which are going to be tested. So you studied all those concepts. You feel you're quite comfortable. You seem to have understood everything. So you go back to those same set of questions now, and then you try to answer them without looking at the answers. Right? You answer all of those. Earlier you had looked at the answers, of course, but now you're taking those questions and answering all of those questions without looking at the answers. Let's say you score 95%. Okay. Now, would that be an indication that you're likely to score 95% in the real exam? I would think not. Okay. That is because these are questions whose answers you have seen many times before. The correct answer is known, right? So you might be answering those questions correctly just from memory. Who knows? Okay. So testing yourself on the same set of questions that you used to prepare for the exam is not a great idea. What would be a better idea is if somebody came and gave you a new set of questions that tested the same concepts, but the questions are now different, right? You take an exam which is consisting of the new questions, and if you score 95 on that, then you say, okay, you really seem to be well prepared for the exam. Okay, that is what we are looking at here, right? So coming back to our data analysis, what we really want to do is you need to evaluate the model quality on data that was not used in building the model. This is different from what we did here, right? Here, you use this data to build the model, and you're using the same data to test the quality of the model. That's what you're doing here too in the exam prep, right? You used a certain set of questions to study for the exam, and after finishing study, you're using the same questions to test yourself. No, that's not a great idea. Okay, so what we really want to do is you want to evaluate the quality of a model on data which was not used to build the model. It should be new data, something that was never looked at while building the model. Just like a set of questions that you never saw before, but they are on the same concepts. So if you do well on those, then you're prepared, right? So if you do really well on the set of questions that you use for preparing for the exam, and you completely bomb on the new set of questions, then it's clear you're not ready for the exam. Similarly, if you build a model, you test it on the same data with which you built the model, and the performance was stellar, but then you give new data and the predictions completely fail, then the model is not a good model. So this is very important. You need to test the quality of the model on independent data. In other words, data that was not used in the model building process. Okay, so now suppose you have historical data. You use that to build a model. Now on new data, you apply the model and you generate predictions. Under what conditions will these predictions be good? Right? The conditions under which these predictions will be good is that your new data, your historical data should be representative of the new data. Right? Then if the model does well on historical data, you can expect that it will also do well on the new data so long as the new data is representative of the historical data. Okay? I'm sorry, the historical data is representative of the new data. Okay, so now let's understand, given that we understand this, that there's no sense in testing the model using the same data that was used to develop the model. Typically, what is done is you've got available data, and in predictive modeling, what you do is you divide the data into two parts, sometimes more. We'll talk about that later. You divide the data into a training and a test set. Okay. In other words, what you're going to do is, let's say you have a data set with 100,000 rows. What you're going to do is you're going to take about, let's say, 70,000 rows and use that for model building. And you're going to take out 30,000 rows and just put them away. Don't even touch them. Don't even look at them. Completely. Take out 30% randomly. Just keep it away. Build the model only using the 70%. Then once you have developed the model using the 70%, now test the data, test the model on the 30% that you did not touch. Now remember, all of your 100,000 rows are historical data. So for every single row, you know the correct answer. right? Because this is historical. You know exactly what happened. You know the correct answer. So what you can do is to build the model with 70,000. Then on the remaining 30,000, you use the model to make a prediction. And then you can compare the prediction of the model with the actual value and then see how good the model was. That's what we are going to do here. And this process is what we call as supervised learning. Okay, so let's say here is your complete data. Of course, I'm taking a some small data set, and here is the training partition, right? That is the 70,000 that you put away in training, and the remaining is called the test partition. It's called the test partition because this is what you're going to use to evaluate the model, and this is called the training partition because this is what you're using to help the machine learn the patterns. Okay, so this is giving training to the machine so that it can learn the underlying pattern. Once it learns the underlying pattern, you have the model, you can apply the model on the test partition. Okay, so this whole process is called partitioning, and this method of learning is called supervised learning. Okay, so let's see how it works. So here's your training partition. Okay, and I'm just showing 4 rows here. But what you're going to do is to look at the training partition, the data in the training partition, and the machine is going to learn from this. So it's going to learn some way to figure out based on based on the predictor attributes like income and education level. Based on those two, it's going to figure out a way of finding out how whether a person is going to be an owner or a non-owner. That's the model. Okay, somehow looking at this, it will figure out a way to find out if a person is owner or non-owner. Then it goes to the test partition. And of course, test partition has also got whether a person is owner or non-owner because it's part of the original historical data. But then it can apply the model. It figured out a model here. It can apply the model and generate a prediction as well. Okay. So for example, for the first person is a non-owner, the model may say the person is a non-owner. Second person is an owner, the model may say the second person is also a non-owner. The model would be wrong, but the model is. So you can generate the predictions by the model for every row of the test partition. Okay, so in this above example, how might you test the quality of your model, right? So here is the actual value. Here is what the model said, right? So I'm saying, given this scenario, how might you measure the quality of your model? Think about it for a minute before we continue. You can pause the video, and once you have some kind of an answer, take a look at what I have to discuss. Okay, the point is, how will you say, is this a good model or a bad model? Well, one thing you could do is the following, right? So here is the actual value, here is a prediction. You can always see how close were the predictions to the actual values, right? In other words, let's say there are 100 rows. Out of the 100 rows, in how many rows was the model correct, right? What proportion of the model's predictions were correct? That's one good way. You may say, well, the model predictions were correct 90% of the time. Well, that's one evaluation of how good the model is. Okay, so basically compare the model prediction with the actual and see that. Okay, so how will you measure this numerically? Just like I said, right, you can say percentage of correct classifications, or you could do percentage of cases in which owners were misclassified, right? Because it's not only a matter of saying, okay, the model is correct 99% of the time. You may want to say, well, how correct is the model when it comes to non-owners? How correct is the model when it comes to owners? You might also look at those kinds of proportions. So all of those are concrete numbers which will give us an idea about how good the model is. Okay, and again, at this point, I just want to give you a very broad overview of what's going on. As we go forward in the course, we'll look at very concrete examples of each of these things. Okay, so here's just something to test your understanding. We are saying here, the university had done a data analytics exercise to build a model to predict the first semester GPA of a set of prospective students. Okay, so it applied the model to data of 1,000 past students. and found the model predictions to be satisfactory. It had used data on a set of 2000 past students to arrive at the model. Okay, so it used 2000 rows to build the model, and it used 1000 rows to test if the model was good. So my question is, based on the above, data on how many students was in the training partition and data on how many in the test partition. Okay, so think about this again. It's useful for you to make the effort to come up with an answer. If you need to read the question again, pause the video, read the question carefully, come up with your answers, and then of course I will shortly reveal the answers. You can look at whether you were correct or wrong. It's very, very useful for you to do this on your own before you look at the answer, right? You'll get 10 times more benefit than simply going and looking at the answer, right? Even if you put in the effort and your answer is actually wrong, you will still learn a lot more if you commit to an answer. Okay, so let's look at the answer. So obviously, how many data on how many students was in the training partition? That means how many rows were used for model building. And from the description, you can see here, data on 2000 past students was used to arrive at the model. That's the training partition. Okay, I deliberately reversed the two things. Okay, so obviously the training partition was 2000 and therefore the test partition was 1000.